They're getting bigger. They're getting harder. What am I going to do? Caitlin. What? Yeah, factor. Factor each component. So we're going to factor our numerator, which I'm going to put into two binomials. Okay, and let's deal with our numerator first. So our numerator has to multiply to make a 2 and add to make a 3. What are the signs inside my binomials? Are they both addition, both subtraction, one of each? What do you think, Emma P? They're both addition. Okay. Factors of 2. 1 and 2. Do they add to make a 3?
Yeah.
Yes. All right, that was easy. So now let's do our denominator. So I'm going to take it to two binomials. Okay. Addition, subtraction, one of each. What do you think, Hunter?
Addition.
Addition. Both of them are going to be addition. What multiplies to make 10 and adds to make 7? 5 and 2. What do we see? Alyssa, what do you see?
Cancel out the 2 of the x plus 2.
So you can cancel out this term divided by this term. Makes an equivalent form of 1. So what's my answer to this problem, Riley?
2x.
Nope. Want to try again? No? Who wants to help? Tessa?
1 plus.
Nope. What do you think, Tyler?
X plus 1 over x plus 1.
Yep. X plus 1 is left in my numerator. And x plus 5 is left in my denominator. Okay, so this is my answer to simplifying this problem. But we have to name our excluded values. So what are the values that x cannot be? Kristen. Okay, you're missing one. Aditi. -2. You take your excluded values from here. Because if this piece is equal to 0, then it's going to ruin your whole problem. It's going to be undefined right away. So it's not just from the answer, it's from the beginning part of the problem. And you can see it as soon as you factor it. Okay, Brianna.
How would it be x plus 2, or -2? Because if you plug in for x...
Then you would get -2 plus 2 is 0.
0 but then,
And 0 times anything is
oh, okay.
0, which makes it undefined, right?
If we don't put the parentheses around the terms, points off or no?
If you don't put parentheses around the terms. Oh, in your answer?
Yeah.
No, I won't take points off, but you should practice putting them there because these things are locked together. Okay? And so you want to keep it locked together and show that because that's how you make sure that you're not canceling anything out that you're not supposed to. Okay? Other questions? You want to do another one? Want me to find a harder one? You want an easy one or a hard one? Raise your hand if you want a hard. All right. Let's do one more easy and then I'll do a hard. Okay, one more easy. Let's do 5. This is kind of a medium. 5 plus 4z minus z squared over z squared minus 3z minus 10. Okay, so what's the first thing you notice? What's the first thing that's weird about this problem? See if you can finish this one for me. Kerouac, what do you notice?
5 is before the
The z squared. Why'd they do that? What? Yeah, just to change it up. Why else do you think they did it? What don't they like? What do you think, Nina?
A negative on the age.
They don't like the negative on the end. So they moved it. So I can move it back. And I would have negative z squared plus 4z plus 5. Is there anything wrong with doing that? No. But what are we going to do first? Before we factor this into two binomials, Aaron? Take out a negative. So we're going to factor out a negative 1. And what am I left with? Caitlin?
Z squared minus 4z minus 5.
Over, and we still keep the rest. Okay, now what? Now what's my next step? Olivia?
Factoring out.
Okay, tell me what I'm going to get for my numerator.
Negative 1 and 5.
A negative 1.
So you're going to have z plus 5 times z minus 1.
Okay, well then that's going to give me a positive 4.
So we want the negative on the 5.
You want the negative on the 5 and the positive on the 1. And they're going to add to make a negative 4, so that works. Okay, and now my bottom, who can help me, has to multiply to make a negative 10 and add to make a negative 3. What do you think, Tessa?
Negative 5 and 2.
A negative 5 and a positive 2. So we have a z minus 5 and a z plus 2. What do we see? What do you see, Hunter?
An equivalent form of 1.
Okay, which is?
Z minus 5.
Okay, so there's our 1. What's our answer? What's our answer to this problem?
Negative 1 times the quantity z plus 1 over the quantity of z plus 2.
Does your negative have to stay in the numerator?
No.
No, why not? Caitlin?
Because a negative divided by a positive is going to be a negative, and a positive divided by a negative is going to be a negative.
So what we're saying is our whole answer, no matter what it is negative. Okay, what are my excluded terms? Because we can't forget about them. Z cannot be what, Aaron?
5 and negative 2.
Yep. Okay, so there's always excluded terms in here because you can't have your denominator to be a 0. All right, does that make sense?